Hello, everybody, and welcome to this episode of the Ampere Developer Impact. Today, I'm joined by Jim Halfpenny and Maximilian Wittich from Stackable. Thank you for joining me, gentlemen.
It's a pleasure to be here.
Thank you for having us.
You're welcome. It's my pleasure. Jim, to get us started, can you tell us, for those who aren't familiar with Stackable or who haven't heard of the company before, what exactly is Stackable and why would people want to use your product?
Well, in a nutshell, Stackable is a 100% open source and free data platform. We all worked in the big data industry. We saw some really great open source software there. So we've taken a curated list of some of the most popular open source products for ETL, for data streaming, processing, and analytics. We've built a data platform around that. And effectively, what we've done is do all the operational work so that you can define your data platform using infrastructure as code and really easily get up and running with, I say, some of the finest open source software out there.
So what does a data platform consist of? Everything from data ingestion, processing, all the way to presentation? Or like what parts are included and what parts are not?
Yeah, so we've tried to make the Stackable the core fundamentals of a data platform. So we've cherry picked things from, for instance, we have Hadoop HDFS for storage, but we've also left out from some of the more sort of legacy parts of it. Everything we do runs on Kubernetes, so we don't have a scheduler like Yarn for those from the Hadoop world. But we've got tools that do streaming analytics with Apache Druid. We've got Apache NiFi, which is great for moving data around and transforming it, putting it into all sorts of different formats and landing it anywhere you like. But we've also got other things like Apache Superset for visualization and analytics, and we have Trino as our distributed SQL engine. So we've tried to fit all those sort of major components that you'll get in a core data platform. Perhaps not the most
that's a really good overview. But so I am curious, like when somebody installs this, how much integration do they have to do themselves, and how much of the integration comes with your platform?
Yeah, one of the key things we've tried to do is get that integration all built into Stackable, and we've relied heavily on Kubernetes as our control plane for that. So if you deploy something like Apache NiFi that requires a Zookeeper cluster, we can deploy a Stackable Zookeeper cluster, and we've got discovery config maps there. We can just reference things by names. It just takes a lot of the sort of the nitty gritty out of getting all the configuration down, and should make life easier. And again, just to mention, we've tried to do everything infrastructure as code. So there's no more click ops, no more sort of driving a mouse to try and build your data platform. You can check all your configuration into Git. You can version control it and roll it out with your favorite CI/CD tool.
Brilliant. So can you give me an idea of like what kind of problems your product solves, and who are what's the target audience for your application, and what kind of applications they're doing with Stackable?
I guess our target audience would be anybody who needs to build themselves a data platform. And just to sort of elaborate on the sort of customers we're looking at, a lot of these products, are great for running on premise, but we've seen a lot of the sort of the big data space aggressively move towards cloud. Now, if you're either stuck on premise or you want to build a hybrid platform based on, either multi-cloud or on-premise and cloud, Stackable is great because it runs anywhere. Anywhere that you can run Kubernetes, you can run this. That means you can run it on-premise. You can run the same software in any cloud vendor, not just the hyperscalers. Our run anywhere thing is part of our openness, and I think it's a core strength there.
Okay, and given your run anywhere kind of culture, the fact that you run on Ampere CPUs is not exactly surprising. But can you tell me a little bit the story of how you came to port your product to Arm64 and what part Ampere played in that process?
Yeah, I mean, I think initially our interest was piqued because a few of our developers were picking up MacBooks, and as you know, they're ARM-based laptops. Now, we wanted to make our software accessible to everybody, But that made us realize that there's actually a market out there for ARM processors in servers, particularly from Ampere. We've seen Ampere processors in physical kit, we've seen it in cloud, and there's a whole unique sort of story around why Ampere's a strong challenger in the CPU market in terms of sort of performance, core density, and that it just seems to fit well.
Yeah,
and
we do try to try to.
not too much flattery there.
Thank you very much.
We can see where you're coming from, and it again, part of our open source nature is much of our stuff runs on Java and Python. It seems like a no-brainer to do that. We've got everything containerized, so we build ARM containers, and we build x86 64 containers. And from our point of view, once we've got that build pipeline working, there's not a huge amount of effort for us there. I say that, but I know Maxi's put in a huge amount of effort.
Yes, that is a really nice segue actually to what I wanted to talk about next, which is the actual process of adopting ARM64 as a target platform, and the actual practicalities of doing multi-architecture builds, and again, how Ampere maybe played a role in that. Maxi, can you talk a little bit about the technical underpinnings of how have you done your CI/CD, and what ways did that evolve as you were trying to add the support for ARM64 to your product?
Yeah, as Jim already mentioned, it started all off by some developers picking up macOS on M chips. I was one of those. So we laid 2 years from this point in time. We laid out some groundwork and had already some good fundamentals going, and looked for a strategic partner, which we found in Ampere, like a very, very good match. Ampere was very kind to us, and actually it was HPE who offered us an Ampere server where we were able to develop, test, especially test on it, and made our journey up to multi-architecture.
Excellent.
Yeah.
And yeah, I like that you mentioned the HPE RL300, the Ampere server that they sell, because as you were saying, a lot of people are using ARM64 both on-prem and in the cloud, and Ampere is actually right now one of the very, very small number of ARM vendors that offers you both, right? We are the ARM64 vendor for Azure, for Google Cloud, for OCI, but also we give you that option of using hardware on-prem. So was the availability of on-prem hardware like a really big benefit as part of your migration process?
Yeah, definitely. The on-prem hardware enabled us so much to do consistent testing, to do consistent developing, and make especially ARM64 chips available to the whole community of our developers, which really strived our developing process and our testing process, and was able to propagate it very good into our group of devs, and therefore for the acceptance and support.
Great.
Helped us great way.
Well, tell me, Stackable is made up of a lot of open source projects. Were all of those projects already available on ARM64 when you started? If not, did you have any porting work or any like community building work to do?
Yeah, so 2 years back in time, the infrastructure and the environment we were developing against wasn't as far as we hoped. So we had some problems migrating code to ARM in terms of C-like types, means everything which is not C-like wouldn't run on ARM when it was running on x86. So we had a hard time to compile some stuff on our own. In the beginning, especially like Kubernetes components, like Kubernetes DNS, we had to build from scratch, which is now way better, and the environment developed very, very far.
Right.
So, yeah.
And again, from our prior discussions, I know that you're a big GitHub user. That's where you host your product code, right?
Exactly.
Can you describe the CI infrastructure that you use for your container builds and for all of your CI and testing?
Yeah, for that, I would be happy to show my screen. As we are open source, we can display code and we can show what we have. That's awesome. So what you see is just the stackable tech repo where we just store all our stuff, and I'm gonna specifically show you the Docker image repository where we build from all our products from Docker files downwards. And you're especially interested in our CI/CD workflow. So I just gonna open one. Let's go for Hadoop. I like Hadoop. Yeah, as you can see, this is just an average GitHub workflow, nothing special, bits and pieces right there. But what you can see, and I hope I can find it immediately, we have like runs on metric learner's name, which is just a matrix where we use different runners with different architectures to build natively on each architecture we have. So what we do from the process, we build the product, which is now a reusable GitHub action, and then we publish it as a manifest list of all versions. So what intrinsically happens on every runner, x86 and ARM64, we build an image, we push it, and after we have it pushed, we sign it first, and then we build a manifest list containing all images. To be a bit more precise about it, this is our repository. You can also watch that because it's open. And to give you just a brief understanding of how that technically would look like, we can just have a little look at the tasks and our newest release 24.7, which is out of the door for 1.5 weeks. You can see a specific tag, like perfect. So what you see is the image you want to have. It's like, I believe I'm at Druid. Yes, I'm at Druid 30 from our 24.7 release. And all you would do is like docker pull docker.stackable.tag/stackable product name and this tag, and Docker will decide for you which architecture you have to do, which means if you install it on a Kubernetes cluster, you would have to execute the exact same commands as on x86, and it wouldn't make a difference for a user at all to install our product on ARM or an x86.
So for those who are unfamiliar, the way multi-architecture containers works is you have your containers that are compiled to machine code to an executable for a specific hardware platform. So you have the ARM64 and the AMD64 containers. Those are the canonical names of the architectures. And then you create this manifest, which is just a text file, right?
Yeah, more or less, it's a JSON string.
Yeah, which is a JSON file, which says, if you're trying to pull an ARM image, pull the ARM64 image. If you're trying to pull an x86 image, pull the AMD64 image. And you can do multiple platforms, right? You can do ARMv8, you can do PowerPC, etc.
Yeah, and the best thing is you can do it all together. If you have a cluster with mixed architectures, one node is x86, one is ARM64, it still would automatically assign the correct image to the correct architecture, and you would have the same look and feel as you would have on one architecture.
Brilliant. And to actually do your GitHub builds, how do you? Because I know GitHub is releasing soon GitHub hosted ARM64 runners, which are also going to be powered by Ampere. By the way, they're running on Azure. But how do you do your builds today? Are you using that, or are you using something else?
Yeah. The problem with the GitHub runners is that every repository we own is a public repository, as we are an open source company, and those ARM64 runners are currently only available to private repositories. Therefore, we were forced to move on to third-party vendors, where we started off with BuildChat, which was super sufficient and fine as long as we weren't building our products from source. And as we choose to do so, we needed greater capacity, especially when it comes to memory. And therefore, we changed to UbiCloud, to UbiCloud ARM64 runners, because they have just greater resources to offer.
I do think by the time this video is available on YouTube, just for our viewers, I believe that we may have gone that the GitHub runners may have gone GA. So if they have, we'll include a link to that announcement in the show notes if it's appropriate and timely. Thank you, Maxi, for the overview. So BuildJet was insufficient, but UbiCloud has given you a lot more control in terms of the size of VM instances that you use. Is that right?
That's correct, yeah.
Okay. And did you have to do a lot of work to enable, from a Kubernetes perspective, that, for example, the daemon set was working cross-architecture, or, do you have to, is there anything in particular that you have to do in terms of the configuration of your Kubernetes operator? Or is it straightforward?
No, it was super straightforward. Once we have like manifest lists and multi-architecture available, it just worked out of the box.
Okay.
It's not a huge problem for anybody. Yeah.
It looks like we're running.
We're getting somewhere. Yeah.
Oh,
get somewhere.
Oh, yes. So let me ask you about it. Congratulations on your new product release, by the way. So let me ask you about your testing and any performance testing you do, or minimum, like even just your quality testing. How much did you have to evolve your test infrastructure to validate your product on multiple architectures?
Well, at first it seemed complicated, but since we have now replicated on board where we can just choose definitions of clusters how to test, it became just another string. The hardest thing to do was on deciding on a test strategy for Arm64, because we want to test an integration test. The main functionality of our product means we don't expect big changes from one architecture to the other. And therefore we came up with the strategy to test once a month only on Arm64, and 3 other times we test the x86 sides to ensure both sides of the product are working.
Okay. Yeah. Jim and Maxi, how have you worked with Ampere, and how has that experience been working with both Ampere the company and with Ampere hardware?
It's been a really positive experience. I mean, it's first of all, been able to get some hardware. We're a startup. We don't have as deep pockets as some other companies. And first of all, just getting that assistance in getting up and building so that we can actually support multi-architecture has been really, really useful. But also it's been, it's been an eye opener. Just, we've seen Ampere just popping up lots of different places. Like you say, they're going to be running I think you already mentioned the GitHub runners based on ARM. So that'll be on Ampere. We've seen Ampere on lots of cloud providers, not just big ones, some of the smaller ones as well. So it's nice to see this popping up there, and so far it's been a really friendly and sort of interesting, dare I say, fun experience sort of working with you folks. So it's been good. I don't know if Maxi's got his own take, but
yeah, I would say the same. Like, integration to Ampere was super seamless. Working with you guys was a joy. Can only report positive.
Yeah, my pleasure.
We have a super easy integration where you can just sign in with Keycloak. It knows this instance. I already put it into credentials. This means my session is complete, and I refuse to reset cookies just right now because I don't really know what it would do to our session. And this error is because the data is not loaded. But what the demo will show you is how our access control and our rule control via Open and with Keycloak together can bring your views and your security really to the next level, because you can restrict right in our product as code how different users and user groups would experience the surface of Superset. And therefore we
provide a one-stop single sign-on experience for all of these data products. Is that part of the product?
It's where we're headed. Because all of these open source projects have different developers and everything behind it, there is varying degrees of support for things like OIDC, but we're aiming to try and standardize on the more modern authentication sort of platforms across all of them. So where the features are available, we're building and integrating them. It just it's one of the challenges of working with open source is they're not all from one vendor. There's always that little bit of friction, but we're trying to minimize that by, as they do that work for you.
Right. Okay. And tell me a little bit whether you have seen any interest in the market for running Stackable on ARM64, whether it's on an Ampere processor or another vendor.
Sorry, I thought Max was going to speak there. Wait, okay, I'll take a pause and I'll jump in there. We're starting to see more of it, and certainly it's a consideration now. A lot of the customers we've got are replacing their existing data platform. They've made a big investment in hardware in the past. Maybe it's 5, 6, 7 years old, and it's time for renewal. So Ampere is appearing as one of the options for that. They're going to make another big investment on a data platform, and as I say, the unique selling points of Ampere do come up in conversation.
Right. So power is a concern for your customers, core density, the ability to run kind of power efficient hardware on premises is something that people care about in your customer base.
Yeah, absolutely. Power is one of the big power and cooling. Yeah, the big one, but also the sort of the rack density. We're finding that often with customers, rack space is at a premium, and being able to get more cores per U is actually something that they're sort of looking for, and particularly when you've got some compute heavy workloads. For instance, we looked at partnerships with companies that provide the storage solution. But then they want to give us, what can you get in half a rack? And you can get a lot more if you've got more cores.
Right.
Simple bit of maths.
Yeah, and that's something anecdotally that I've seen as well is that a full 42U rack typically can only have in a data center a couple of years ago can only have maybe 20U of actual hardware in there because you got to leave space for airflow, right? Whereas that's, and I don't mean Apache Airflow, which I know is part of your platform, but that's less of a concern with Ampere servers. Absolutely.
By the time you put a top of rack switch in and a bit of other network kit, you start to cut down what you've got on there. And yeah, from what I understand, it's expensive to go to 2 racks instead of 1, or 3 racks instead of 2. So it's again part of that total cost of ownership isn't just the power saving and the cooling and that. It's what the footprint is. And data centers are still expensive.
Right.
Those that still run them are still trying to reduce their footprint constantly.
Can you show us your product in action?
Yeah, sure. I've prepared some demo for you. So what you see on the right-hand side, we already pre-installed our operators on the right version you want to have. You can just let our tool do that, or you can just skip release right after. Or you leave it as is, and our tool is going to know which components are already installed and just skips the installment.
And SCL is an alias that you've created for Stackable CTL, your CLI tool.
Exactly. So just let me make sure it's going to install, which it does. That's awesome. So I can show you where you get it, actually. So you can go up to our Stackable docs, which is on docs.stackable.tech. Go to the quick start and then install for the system you like, especially example is Linux. You can wget or you can curl the current binary, chmod it, and then you can just already use Stackable CTL demo install, and then whatever demo you like to install.
Okay.
We have a few of them, so you can already choose.
Is Stackable CTL also available for ARM64, or is that like Stackable CTL is x86 only, and you install ARM64 packages? What's it? How does it work?
Stackable CTL is a pre-compiled binary available for x86 and for ARM64 already. So you can, as we strive that our developers can choose their system as they wish. So we try to support really everything we have. So ARM and macOS fall into that league, obviously.
Okay.
Yeah. So we have everything ready, multi-architecture already.
Perfect.
Yeah.
For those familiar with Kubernetes, a lot of what Stackable CTL does is a bit like a wrapper for Helm and kubectl, kubectl.
Yeah.
So we're just, like I say, we've written code that defines what our environment looks like, and it plays that into the Kubernetes cluster that you've got defined. So you can run Stackable CTL on your workstation and interact with a cloud cluster, for example.
Okay. And for anyone familiar with Helm, obviously they recognize what's going on the right here, which is we're pulling a set of containers, we're running them in order in an order that's defined by the Helm chart. And you have, Maxi, you were saying earlier, you have some expected backoffs where containers try to start, but their prerequisites aren't started yet. So this is kind of the normal way that that Helm charts work to install applications.
Exactly.
Yeah, we're deploying lots of things, and then they're waiting for their dependencies to be reconciled, and given enough time, you've got a perfectly working cluster.
So can you explain briefly, Maxi, how, because I know that some of these containers are running on multiple architectures and there's nothing particularly indicating that. Can you explain how that works? How does kubectl or Docker or Podman or whatever container orchestration tool you're using, how does it know which architecture to pick?
Yeah, of course. Just let us use this example because it's right in front of us. As you can see, that's the wrong one. We pull a very specific image with a very specific tag. In this case, we have Docker Stackable tag, Hadoop, and a tag of the image version and the release version. And when we go to our repository, we now looked at, I believe, Hadoop. You can see when you go into the Hadoop stuff, which is here, go to tags. We don't use 3.4 right now, we use 3.3.4. As you can see, this is the tag we pull from, right? Mm-hmm. And this tag is nothing but a manifest list, which is nothing like a JSON string with informations, which image it contains, or it wraps if you want so. And under this, it lies two different images, one with an AMD64 tag and the other one with an ARM64 tag. And the runtime of Kubernetes or Docker or Podman or whatsoever knows the architecture it's running on, and therefore just seamlessly selects the right image to the right architecture. So it's, on the user perspective, nothing won't change. You still pull the tag you used to as you would have done with x86.
So this is what you explained when we were looking at your GitHub Actions, is you build your ARM64 image on Ampere, you build your AMD64 image on an x86 server, and then you create a manifest that contains both images in one and says, if architecture is this, then you pull this image, and if it's the other, you pull the other image.
Exactly. That's how it looks, yeah.
And from the perspective of Kubernetes, like, how can you tell which platform you're running on?
How I can tell from Kubernetes?
Yeah, for example, looking here, we have. Let me pick an example.
I see what you see where you're picking from.
Oh yes, so you've got your daemon set here running. That's going to run on every node, right? So
that's correct.
From the perspective of the application user, like, it looks like it's just transparently running on both architectures. Is that how it works?
Yeah, basically it's running the same thing on both architectures, and we can verify that pretty nice. So K9S gives us the opportunity to shell into a specific part where we find the command arg, and it's going to give us back on which architecture it runs. So this pod secret operator is running on Ampere's ARM64. We can just go a little down there, and I believe this pod is scheduled on x86. Yeah, and that's the concrete evidence that we are running on both architectures and everything is working together as it's supposed to. And additional, I have good news. Sorry.
Mm-hmm.
Our jobs are finished, so now our stuff will be ready to visit.
Oh, excellent.
Yeah.
I do have a question, and I don't know the answer to this question. Is like, if you're running a replica set, that can deploy pods on either architecture. How do you know which architecture is going to choose for one pod or another? Can you control that? You use affinities basically to say, or do you use like
so from a user perspective, you could use like taints or affinities to choose the node you want to have. But in general, Kubernetes is going to choose the node it thinks it's the best and has the most resources available. So it chooses the architecture randomly, if you want so, at this moment here.
Right. Okay. Well, let's see what the demo is looking like.
So what we have is superset. I already logged myself in with Keycloak and our users. You can just find them into the demo. I choose to log in with Daniel King, which is a member of the compliance analytics team. So it makes sense. You can see like compliance stuff. And now where we have actual data, we can just peek a little bit into it. It's loading.
Oh, thank you. Can you zoom just a little bit in on this, please?
As much as you wish. Yes.
Ah, thank you. Perfect. My eyes are getting old. Let me put it that way.
Here to make you happy. Awesome. Yeah. And as you can see, that's the data we just saw was loaded from our script, which is now completed.
Okay.
Yeah. And that's just basically what superset does. Yeah.
Brilliant.
Do we have some more dashboards here? I don't know. Yeah, we can see some more smaller stuff just to display the capabilities. Now we're not looking at a dashboard, we're looking at a chart,
right,
which is basically what the dashboard would use in the
end. This would be very familiar to somebody who was familiar with Apache Superset.
Exactly.
Oh, yeah.
Okay.
Yeah. And this already shows our integrations to Keycloak with Superset, which is part of our platform. I would say good integrated already.
And so Keycloak is what's used for authentication and access permissions.
Yes.
So you have an integration with a single authentication application for all of the Apache projects in your product.
As far as is possible. So there's differing degrees of support across the ecosystem, but we're certainly making efforts to integrate more modern authentication schemes like OIDC wherever we can. Some parts just don't contain that. Maybe it's not appropriate or it's just not been implemented yet. But we're aiming as much as possible to sort of uplift the security to the most modern and capable sort of authentication schemes.
Right. Yeah. Okay. Well, thank you very much for the demo, Maximilian.
It's a pleasure.
Let me finish off with this. Jim, Maxi, obviously we've seen where people can learn a little bit more about Stackable and use the product. I'm going to link to the stackable.tech webpage again in the show notes here and your getting started documentation. But what's next for Stackable and Ampere and Stackable and Arm64? Like you've just released your product. Where can people find out more? Where can people get going trying your product, and how can they contact you if they're interested in your support in using it?
I think our documentation page, which we mentioned, docs.stackabletech, is a great place to start. If you want to get some hands-on, like I say, there's a quick start guide there, but there's documentation on all of our Kubernetes operators to manage all this there. And if you visit stackable.tech as well, you'll find some links on there to get in touch with us. So you can drop us an email as usual at info@stackable.tech. But we've also got a Discord server. So we're trying to build a community of people working with this open source software. So you can come and have a chat with us. There's usually someone there who's there to answer questions or help you out with your problems.
Brilliant. Yeah. Okay. Well, thank you both for joining me today, yet again. And I just want to finish on this note that if you want to learn more about other customers who are using Ampere hardware, or if you want to learn more technical details about using Ampere hardware, improving performance of applications on Ampere. You can get a lot more information at the Ampere Developer Center. You can also talk to us directly on the Ampere developer community at community.amperecomputing.com. And obviously, we will have a lot more information from Stackable on the Stackable website, and we will also be putting together a case study based on this conversation. So again, Jim, Maxi, thank you both for joining me today. I think we're pretty much at the end of our time together, but thank you all, and for all who are still listening to me drone on at this point, I look forward to seeing you at a future episode of the Ampere Developer Impact.
Well, thanks for having us. It's been a pleasure.
Thank you.
The pleasure is all mine. Thank you.